Subscribe now and press the bell icon. Never miss an update.
The control panel of a generator is located in the main switchboard. Assume that number 1 generator is running on load. Number 2 generator needs to be started synchronized with generator 1. Start the number 2 generator. Check the voltage and frequency of the generator. If the frequency is 62 Hz, decrease the frequency of the number 2 generator. This is done by using the governor motor control switch in the panel. This decreases or increases the speed and hence the frequency of the generator too. Switch on the synchronoscope selector to number 2 generator. If the needle rotates in clockwise direction, the speed of the incoming generator should be decreased. If the needle rotates in anti-clockwise direction, the speed of the incoming generator should be increased. The air circuit breaker should be closed when the incoming machine voltage is in phase with the bus bar voltage. It is advisable to close the breaker when the pointer rotates in clockwise direction. The actual synchronism between the two generators is indicated by the 12 o'clock position in the synchronoscope. Close the air circuit breaker when the needle reaches at 11 o'clock position, taking into account the breaker closing time. There are 4 important conditions for synchronization. They are phase sequence matching, voltage matching, frequency matching, and phase angle matching of both incoming and running alternators. Let us see the first condition, that is, the phase sequence of incoming alternator should be matched with the phase sequence of running alternator. For example, the phase sequence of incoming alternator is RYB, then the phase sequence of running alternator must be RYB. At this condition, both the alternators are rotating in same direction with same phase sequence. If the phase sequences of incoming alternator and running alternator are not same, then they are rotating in opposite directions. The second condition is that the voltage of incoming alternator should be matched with the voltage of running alternator for a proper synchronization. A 5% of voltage difference is allowed between the alternators. If there is a difference in voltage levels of more than 5%, then there will be flow of large amount of circulating currents in the internal circuit connecting the two alternators. If the synchronization is done with a lot of difference in voltages, it may cause damages to both the alternators. The third condition is frequency of incoming alternator should be matched with the frequency of running alternator. The frequency of the incoming alternator and the running alternator will be equal when the alternators are rotating at same speed. A difference in frequency indicates that the amount of stored energy in the rotor of the incoming alternator is either greater or less than the running alternator. Therefore, if paralleling is carried out when a frequency difference exists, a surge will take place. The fourth condition is phase angle of incoming alternator should be matched with phase angle of running alternator. The phase angle between the two alternators should be within 6 degrees. This condition can be obtained only when the frequency of the two supplies are the same and the phase sequences are also same. A difference in phase angle between the running and incoming alternators at the moment of paralleling will produce synchronizing currents. You have learned the required conditions to be satisfied for the synchronization.